Hello, my friends. Our next talk will be in English. Before we start, just remember to scan this QR code and follow to leave comments and feedback. It's very important for us. I start learning domain-driven design after reading Eric Evans' book in 2013. As a Chief Technical Officer, I am interested in my employers to improve their experience to make complex products. And I will like to introduce our next speaker. He is co-founder of Velosoft company and system architect, Halil İbrahim. I think let's start and tell all of us how to implementing domain-driven design as a pragmatic developer. Good luck.
Спасибо. Привет. Sorry that I know only this Russian and some Horosho and something like that. 6 years ago, I was first time in Moscow for that next event again. It was one of my first talks, in such international talks. Now, after 6 years, I'm very happy to be here again and with you. I will introduce myself a little bit in details, but first, I want to start with a simple phrase like, you know, Johan Cruyff is a great footballer in football history. Has a very famous quote like, playing football is very simple, but playing simple football is the hardest things there is. I asked to ChatGPT if this is translated to programming world before, and I see that this is the first time I say that. Writing code is very simple, like everyone can write code, but writing simple code is the hardest thing there is. So I can write my name is under that code. But what is simple code? Simple code is easy to understand, easy to read, easy to maintain. This is the maybe main purpose of every software pattern, including domain-driven design, is to create a maintainable code base. It follows the same principles and same coding style in everywhere in the solution. So you can easily know where to find when you look for something. It doesn't contain duplications in business logic especially. Of course, it can contain some duplications for use cases. However, for your core business logic, it shouldn't have duplications. Otherwise, you change some place and forgot the other place. And, you know, a use case doesn't affect others. So when you change a use case, it doesn't break other use cases, and it follows solid principles, of course. I am Halil İbrahim Kalkan. I started programming at 1997. Who has born after this year? Okay, we can include you. I'm a very old programmer. I graduated from computer engineering. Then I worked like 7 years in 2 companies as a software developer, software architect, team leader, and various positions. And then in 2013, I created the ABP framework project in GitHub as an open source framework project. And I still continue to lead this project. 3 years later, this project has become very popular, and we have established a company. So I am one of the co-founders of this company, Velosoft. I'm especially interested in multi-threading, distributed microservice systems, like software architecture things, object-oriented programming, DDD, and so on. But I'm managing a company, but still very active coder on GitHub. You see my profile. In last year, it's not very good, but I'm still trying to spend my time for programming. Okay, today we will first talk about what is the domain-driven design. This part will be very short because this talk is practical talk, not theoretical talk. So I will talk about the general architecture and layers of a .NET solution. Then I will show the execution flow of a typical DDD-based application. I will mention about some common principles. Then we will go to the second part, the implementation part. I will show how to layer a .NET solution based on DDD principles. And I will give many rules and best practices. These rules are simple rules, but when you follow, you will have a maintainable, well-organized code base. Of course, I will give many examples. Let's start with what is DDD. DDD means domain-driven design is an approach to software development for complex needs by connecting the implementation to an evolving model. This is the definition by Eric Evans. So it's for complex applications. It's mostly focused on the core domain logic rather than the infrastructure. Like it doesn't interest if you are using Entity Framework Core for ORM or like another tool or presentation layer. It just focuses on core domain logic and make some suggestions for that. It's suitable for more complex applications, not very like short-time projects. So if you want to create a large-scale code base, it's good. If you, when you implement DDD rules and DDD principles, the promise is that you will have a flexible, modular, and maintainable code base. It's especially based on the object-oriented programming principles and clean architecture. When it comes to layering, typical DDD project, we have domain layer that includes core business logic. We have application layer that implements use case of the system. We have presentation layer typically. It can be a mobile application or web application, doesn't matter. And we have an infrastructure layer for third-party library integrations and integrating the third-party systems and so on. Clean architecture actually is another representation of the very similar principles. In DDD especially, we will focus on the following core building blocks today. In the domain layer, we have entities, value objects, aggregates, repositories, domain services, and specification pattern. In the application layer, we will focus on data transfer objects and application services. So in practical, we have created a layering model based on DDD. It doesn't exactly follow the same naming. However, in practical, we splitted the application layer 2 parts, domain layer 2 parts. Here we have Entity Framework Core as an infrastructure library. You can put it in an integration project. However, we have separated it. Test projects and the web layer. So in the domain layer, we have split it in 2 parts because in the domain shared project, we contain some constants, some enums, and some other types that is shared among all the solution, all other projects. The application layer has also split it in 2 parts. The contracts package includes the interfaces and data transfer object, so you can give your contracts package to a third-party client. They can use your abstractions without depending on your implementation. That is located in the application layer. And for infrastructure, you can create a single layer or another like multiple project for each your major dependency. Here we have Entity Framework Core package for DB context, like configuration mappings and repository implementations especially, because repository interfaces are defined in the domain layer. And finally, we have presentation layer. and some test projects. This is the standard model we are suggesting when you start with the ABP framework today. ABP framework is an open source application framework for .NET. Its main architectures are multi-tenancy, domain-driven design, microservices, and modularity. So we are making some suggestions as best practice to developers. Okay, let's see also the relations between projects in this example solution. We have a domain shared package, as I said. The domain uses it, and we have application contracts package that depends on domain shared, so it can reuse the same enums, constants, and some other primitive types in the data transfer objects and interface definition. Application layer depends on the domain because it uses domain objects and also implements application contracts, interfaces. Infrastructure or anti-framework, for example, here depends only the domain layer because it only maps the entities to database tables, doesn't depend on application layer, for example. And web layer depends on only the contracts package, not only the implementation package. In this way, it cannot access to entities, domain services accidentally. Okay, when you implement domain-driven design in your application, typically this execution flow happens when you have a request. For example, if you have a web application or HTTP API project, you will have an MVC UI on the presentation layer, for example. Typically, when you get a request, it is redirected to the application layer. Just your controllers can inject application service interfaces, sense data transfer object. Application service internally uses the domain layer, like entities, domain services, or repository interfaces to implement that use case, and returns data transfer object if it is needed. In every layer, there are some additional cross-cutting responsibilities. Like, for example, in the application layer, you need to handle also authorization, validation, maybe audit logging, definitely some kind of unit of work pattern for database transaction management, and so on. So this was the big picture. We have some common principles while implementing DDD. First, as I said, DDD doesn't interest in the infrastructure layer too much, and it wants that your project is database or ORM independent. It also doesn't want to depend on a presentation technology because it's rapidly changing, you know. And it doesn't care about reporting or mass querying. It focuses on state changes of the domain objects. That means if some change will happen on your entities or database tables, however you think, it focuses on how to implement these rules. It doesn't, the reporting part is not part of the DDD. Okay, let's start with the implementation part, how to implement these patterns or principles. As an example, I will use GitHub issue aggregate. Here you see we have a repository. This is the issue body, issue text, title, a state like open or closed for the issue. It's assigned to someone, it has some labels, and it has some comments. So this is the model. We will talk about this today. And when we model it with aggregates and entities, we have an issue aggregate here. In the issue aggregate, we have the issue as an aggregate root. You see we have some closed boolean, text, close reason, some assigned user ID, a collection of comments, and a collection of labels. Repositories like have a reference to the repository entity, and we have a reference to the label aggregate also, and user aggregate. This is the typical model. We will give examples based on that. So let's start with the principles before the rules. For aggregate root, you know, aggregate root is aggregate is a cluster of objects X together. Like when you have a business on this aggregate, it typically happens on the aggregate root and delegated to sub-entities if necessary. So it's act as single unit. So the first principle is that when you read this aggregate from database, you should read it as a single unit. That means it should include the issue entity and also all sub-entities, like all comments. And the aggregate is responsible for maintaining its self-integrity, validity by implementing domain rules and constraints. So there is a business logic on the entities. So the aggregate root is also responsible for managing sub-entities, and an aggregate is generally considered as a transaction boundary. That means typically in every use case, you work on a single entity, save this single, when you save this single aggregate, then you don't need to have an explicit database transaction. And final rule, it should be serializable. If you are using, for example, a NoSQL database, it should definitely be serializable. Otherwise, you serialize many objects and save into unrelated database collection. It's not required for Entity Framework Core, for example, but our goal is to be ORM independent, so this is a generic principle. Let's see some rules to make this principle possible. For example, in here, the first rule is reference other aggregates only by ID to satisfy these principles. For this example, you see the Git repository has a collection of issues. This is very typical if you are using Entity Framework Core, for example, but for implementing DDD principles, it's not suggested, so you should not define collections to other aggregates. And this example also wrong, like repository is a navigation property here, so it's also not allowed if you follow this rule. So you just need to reference other aggregates by ID, just repository ID. And the second rule, it's not something rule, but a suggestion. You should keep the aggregate small, because you will read this aggregate whenever you need to make a small change. You need to load all aggregate into memory and make some change and save all together. So it should be small to be performant. For this example, we have a role entity or aggregate root and user aggregate root. Role has some kind of collection of users, and user have a collection of roles. So first is not good, because a role can be assigned to thousands of, maybe millions of users. So it's not true to, for example, change, we want to change name of the role, we don't have to load millions of users to memory. So, but for user, it's reasonable, because a user can have a few rules. So whenever we need to work on a user, maybe we want to know his roles or her roles. So it can be possible to add such a role collection. So you should consider object used together. So that means if you use user, you are always using roles. You should think about that. If you are mostly using roles, it's a good idea to put such a collection. You should consider query performance and also the data integrity. We will see data integrity part and validity part in the later slides. For the primary case, for aggregate roots, it's always suggested to define a single primary key. Typically, as a GUID is a good primary key, but it's another discussion, so I will skip this discussion now. For the entities, that means entities are part of aggregates, and it's a part of aggregate root actually. So for entities, you can have composite primary keys, because when you need to access this entity, you can go with organization ID and also user ID. It defines the primary key of this entity very well. So you can use composite primary keys for entities. However, for aggregate rules, we always suggest to use single primary key. Okay, how to design constructor of an aggregate root. Constructor is maybe the most important method of an object because it creates the object. So for this example, we are forcing the validity of the entity at the beginning. Remember that each object, here aggregate root for example, should maintain its self-validity. So it should not allow to create an invalid object. For example, if repository ID is required, it should not allow to create an issue without repository ID. So create a primary constructor, get required arguments, but keep it minimum to not make the entity creation hard. Like if there are some optional parameters, you can make it optional or just don't include in the constructor parameter. Check validity, for example, here text is required and should be, this is not controlled yet, but maybe some maximum length of text anyway. And also, it's a good idea to initialize sub-collections like labels are initialized here as a new collection. Otherwise, after creating an issue, when I try to use labels collection, I may get a null reference exception. So when I create an issue, I know that if even it is empty, there is an object named labels usable. So it's also a good idea to create a private constructor for ORMs or deserialization purposes. For GUIDs, I always suggest to get GUID as a parameter and never use GUID.new GUID of .NET because it creates a random GUID value, which is not good for performance in relational databases. So there are some services or some examples that produces sequential GUIDs. So always use this kind of services and send this sequential GUID parameter here. Okay, we created an aggregate as a valid object, remember. However, you see that text is like, has get and setter here. If we create a valid issue with text, then we can just set it to null again. So it is not valid again. So instead of creating all properties as public setters and getters, just use some private setters and some methods to change these properties. So in this way, we can maintain object validity. For this example, text has a private setter, and we have a setText method. And its closed and closed reasons are interrelated properties. Whenever I close an issue, I need to specify a close reason. If I make it all public, someone can easily set this true without setting the close reason. However, if I make it private and make a close and reopen methods, I ensure that this rule is satisfied. And also, it reflects domain logic and domain rules much better than compared to a public setter and a getter. Okay, we have methods to change properties. We have a good constructor, but we also need to implement business logic related to this entity. Like this entity should implement business logic of itself. For example, if I want to log an issue, there may be a business rule. Like if it's not closed, it doesn't allow to log. So in this case, I can just define some exception classes and throw exception in these methods. This is maybe some developers, when you see that, you might scare that we are throwing an exception from an entity, what this exception will happen. So it's responsibility of upper layers. So you just throw an exception if something wrong, and if nothing wrong, we can just set the Boolean logic. So instead of getting this out of the issue entity, we can just implement the rules inside of the entity. Again, another rule, like when we want to reopen, it should be not locked before, so we can just throw another exception. Okay, we can implement very simple business rules, but what if our business rules require to make some query from database or depend on external services? For example, when I want to assign an issue to a user, I need to check if the user has more than 3 assigned issues. If someone has more than 3 issues, I don't want to assign. This is a business rule. Simple rule, but rule. In this case, an option can be getting the dependent services as a parameter, because we cannot make a constructor injection for these services here. However, this is also not suggested too much. Alternative can be creating domain services. We will come to domain services later, but now, after entities, let's continue with the repositories. A repository is a collection-like interface to abstract the database access logic from the upper layers. So while implementing the repositories, we typically have repository interfaces that is defined in the domain layer, so domain services and also application services can consume these interfaces, and we implement it in the infrastructure layer. It doesn't include domain logic, and also repository interface should be database independent. Of course, it may be very simple to make it database independence, but we see a lot of code base that just returns DB set or some entity framework related objects, or make some assumptions about the infrastructure. So it's best to not depend on a specific ORM, so maybe you can change it later or test it better. And one important principle is that you should create repositories only for aggregate routes, not for all entities. Because when you want to work an entity, you should first load the aggregate as a single unit to memory and work with this aggregate, then save the change to the database. So you always go through the aggregate routes. Okay. Let's deep dive into this rule. Don't include domain logic. It seems very simple rule at the beginning. However, most of the case we confuse about which code is domain logic, which code is data access logic. For example, issue repository has a method to get a list of active issues, inactive issues. It may seem reasonable at the beginning. However, let's see the aggregate route. We have some properties, like if it's closed, assigned to someone, creation time, and last comment time. There are many properties. So this question here is, what is an inactive issue? For example, if the inactive issue logic is like that, it should be open, it should be assigned to nobody, created 30 days ago or more, and there is no comment in the last 30 days. So if this is the rule, actually this is an implicit definition of a domain rule. This should not be included in the repository or data access logic, because we may want to reuse it. How to reuse this expression, for example? Assume that we have an isInactive method on the issue entity. It's very reasonable. We have an issue object that is retrieved from database, and we just want to check if it is active or not. So in this example, I just copied all the logic here. This is very dangerous because we may just forget to change everywhere when we make some changes in this logic. And also, it's not easy to test this logic individually. A solution to this problem can be the specification pattern. The specification pattern in DDD is a name it, reusable, and combinable class. We will see each one in details. It's basically to filter objects based on a domain rule. The definition of the specification interface is typically like just a single method. You get the object and return true or false if this object is satisfied by that rule. An extended version of this interface and more practical and more pragmatic way is to define a second method that converts this specification to an expression. Because all the data access technologies are working with expressions. So if we can reuse this Boolean logic in data access code, it can be much more reusable. Okay, there is also some base class examples. If we create such a base class, we only need to implement two expression. It's very a little more technical, but you can just find examples on the internet. If we define such a base abstract class, then we can create an inactive issue specification class by deriving from the specification. With the implementation, it's very similar. Just we can check same rules and return an expression of that implements this rule. Okay, after creating such a class, we have a named class, we have a reusable object. When we want to use it, instead of creating a specific method on the repository, we can create a getIssues method that gets a specification. That's very useful because we can get another specification also. So here we get a specification and return list of issues. Implementation is very simple because on the implementation side, we can just use where statement and convert the specification to expression. So it will be working on Entity Framework Core or some other technologies. When we want to use that, for example, we just inject the issue repository, for example, then get issues with creating an instance of that specification. So we have actually created the expression instance and pass it to the repository object. It's very easy. Okay, let's return to the issue entity. We have duplication of this logic. How to reduce this duplication? It's very simple. It's in isInactive method, we can just create a new object of inactive issue specification and call it is satisfied by method with this object. So now this logic is reusable and encapsulated in a very simple class. When we change this class, it will affect database queries, it will affect like logic on the object, it will affect wherever we can use it. Not all specification can be without parameter like that. Maybe we may have parameter like a specification that filters issues by milestones. Just implemented simply by checking its milestone ID. A good point of specification is that it's combinable. For example, if you want to get a list of issues in a specific milestone, but we want only inactive issues, we can just combine these issues together with the AND extension method. The implementation of this AND or extension method, like it's a little bit detailed actually, but you can find in AVP framework source code or you can find on the internet. But you know that there is such a technology. If you use this, you will have specification object. You can combine this together with AND or not. Then pass to the repository to get list of entities. Then when you change the milestone specification or inactive issue specification, it affects all the places that is used. Okay, let's come to the domain services. A domain service implements domain logic that depends on external services, repositories, or if you need to work with multiple aggregates or entities, you may need to create domain services because, you know, every aggregate is responsible from itself. However, if your logic contains more than one entity, where to put this logic? So it's best to create a domain service that implements this rule. And also, depending external services is not easy on entities because you cannot inject it in constructor. So when you create domain services, a domain service works with domain objects like entities, value objects, aggregates, and so on, not data transfer objects. Example, we had issue, you remember, we were getting the user issue service for getting the issue count assigned to a user. So instead of getting this a parameter, we can move this to a domain service, like issue manager domain service. In this domain service, we can just use the standard constructor injection to get external services, repositories, or whatever we need, and create and get an issue and user, just these parameters, and implement just business rule. And for the issue entity, we can make the assign method internal. When you make it internal, a method, you know it's only accessible in the same .NET project or .NET package, however you define. So it's not usable on the application layer, for example. For the application layer, your only chance is to use the issue manager's assign method to assign a task to user. So you enforce this, use this domain service method for this operation. Okay, domain services implements domain rules. Application services implements use case of the application. The main principle here, don't confuse about what is domain logic and what is application logic. This is maybe the most hard part is of domain-driven design, because you cannot decide if this logic should be in application service or domain service. We will come to that point. But remember that we should not implement core domain logic in application services. In application services, we typically get data transfer object, not entities, because we don't want to expose our entities to upper layers. Application services typically use domain layer, like domain services, entities, and some other domain objects to implement the use case. Let's see an example application service. Actually, every use case or every application service method has typically 3 parts. The first part is to get aggregate roots or get the related object from database. You need to implement a use case, so you need some objects from database. You get all objects, perform some business logic, and save change to database. Just 3 parts. So it typically injects the related services, gets some data transfer object. Data transfer objects are generally should be serializable because they are serialized to JSON and so on. I don't mean that you should put this attribute because it's for binary serialization, but I want to give that idea to you. Here we use it issue manager as a domain service. We didn't implement the logic here because assigning has some domain rules, you remember from the previous slides. And we know that issue is changed, so we are updating the issue. Always update the entity explicitly. Don't assume change tracking, because change tracking is some ORM technology. It's available in Entity Framework Core. If you, for example, use MongoDB or another database driver or another technology, it may not be available. Then you need to find all the problems in your code. So it's very easy. Just explicitly update all the change in the database. Okay, we said application services get data transfer objects and return data transfer objects. So there are also some principles to how to design these data transfer objects. Data transfer objects, first of all, should be serializable again, because they are typically serialized to wire as JSON or XML or whatever technology you are using. So it should generally have a parameterless constructor, should not contain any business logic, because its purpose is just to transfer data. It should never be inherited from entities or never reference to entities. This is a very common mistake. Sometimes it is done like just accidentally, but we see many code bases that simply inherits entity because of the code reusability. Code reusability is not good at that point. I split data transfer objects into 2 parts. Some data transfer objects, they are inputs of your application service method, and some are output. And there are some differences between designing these DTOs. For input DTOs, only define the properties you need for this use case. It's a very important rule, and you may ask yourself why I define more properties, but it happens. It happens because you want to reuse the same DTO for multiple use cases. So don't do that. If you do that, when you change the data transfer object because of the change of a use case, it affects another use case. For example, you add a new property that is required, but it is not required for the other use case. So it starts to affect each other and makes bugs in your application and so on. So for this example, for example, we have a user application service, create, update, and change username methods. All gets the user DTO. You see, because we are lazy to create input DTO for every use case, we have a user DTO. Okay, we can reuse it here as a parameter, but ID is not used in create, for example, because it should be generated in the server side. Password, for example, is not used in update or change username methods. Is another use case. And creation time, for example, should not be sent by the client. So it's best to define specific input parameters for each use case. Like for create user DTO. For change username DTO. And define only the properties what you need. You may think that this is some duplication, but it's much more maintainable code base. For the input DTOs, also an input DTO can implement only the formal validation with data annotation attributes and so on, but it should not contain domain logic validation. Sometimes we are forcing ourselves to put some domain logic into DTOs. For example, while creating a user, we want to check if it is used before, but we are trying to force ourselves to do it in data transfer object. We think it's a good encapsulation. However, it's a topic of domain services actually, so it should not do that. For like validation, you can use data annotation attributes safely, just simple. For output DTOs, as opposite to input DTOs, it's best to keep data transfer object count minimum and reuse where possible. Of course, we don't want to reuse the output DTO as input DTO. Output DTOs can contain more properties than client needs because we are reusing it, and in some cases it may not be needed, but in other cases it may be needed. So it's good to return an entity from create and update methods, because when the client creates or updates an entity, it will probably need that entity's latest state. Of course, these rules can be flexible where performance is critical. In this case, you may create specific output DTOs for performance reasons, especially for large data sets. Let's see here. We have user application services. We have many methods here, you see. We are getting a user DTO with ID. Okay, no problem with that. However, here we are getting username and email with ID. Like in a case we need just username and email address, and we are creating a specific endpoint for that. It's not a good idea. Just use that and use only username and email parameters. Don't use others. No problem. It's better to keep your code base maintainable. Same for create, get list, or update methods. It's best to define a single user DTO in this case. That's possible to use on each cases. Okay. We are typically using object-to-object mapping, especially for converting entities to data transfer objects or vice versa. When you use some auto-object mapping library, you can use it, no problem. However, you should be carefully, especially some libraries like AutoMapper, for example, has some configuration validation. You should definitely use it Otherwise, you change your entities, you forgot to change your related data transfer objects, and you get the exception only on runtime. However, if you do that, you get the exception when you just start the application. You can see the problems on development time. And also one rule is don't map input data transfer objects to entities, to create entities, because entities has primary constructors, remember. You should use these primary constructors to create the entity. If you blindly map what user sends to your entity without applying any rule, you will have like inconsistent or not valid entities in the end. You can map entities to output DTOs, no problem on that. Let's see an example. You see, we have a issue creation method. We are getting a data transfer object that contains repository ID, text, and so on. Here we are using the constructor, primary constructor of the issue to create a valid issue entity. Then, if the input DTO has an assigned user ID value, then we are using issue manager to assign this issue to the user. If we blindly set like map data transfer object to issue, then we skip this business logic. Here, just create the entity with minimal state, implement other business additional domain actions or additional business roles if necessary, save entity to database, and finally return data transfer objects. You can just use auto mapping in this case. So this is a good example how to create an entity typically. For example, if the entity has much more complexity, this code will be longer, but the general logic will be very similar. Okay, we have talked about application services and domain services. Sorry. This separation, is very important, especially if you have multiple applications that shares a single domain. In this case, you typically have, in this example, for example, we have a single page application that use REST APIs for backend operations of an e-commerce application, for example. You have a public website for your end users, which is for example, MVC UI, and you have a mobile application, but they should all share the same business rules, same core business rules. However, their screens are different, so their input and output parameters are different. Their use cases are different. Maybe there are some limitations on some application, but in other application there are some other rules. So these differences should be located in the application layer. But the domain layer should be same for all the application types. DDD splits business logic into two parts, as I said. Application logic implements use cases and core domain logics. Let's give some examples to clarify it. Okay, issue application service. This is typically gets, creates, or updates some issue entities. You see that we have just injected a domain service, and all methods just delegate the work to the domain service. It's not a good principle. In this case, so why we have application service, just delegating everything to the domain layer? This is not a good principle because application layer has some responsibility. So it's not good. For example, for domain services should not include CRUD methods, create, get, but should include some business logic, like assign, assign issue, or something like that. Also, we should not pass data transfer objects to domain services because it's domain services works with entities, repositories, and other services, domain objects, not data transfer objects. It's application layer stuff. Okay, another example. We are creating an organization. It's not from the same domain, but you know, in GitHub we can have some organizations. Here, organization manager is a domain service. Let's see what responsibility it does, and let's see if they are proper to implement here. First of all, when you want to create an organization, it checks if there is another organization with the same name. This is definitely responsibility of a domain service. Then it checks for authorization, like if the given user has permission to create an organization. This is not a domain service thing. It should be located in the application service, because this code should be reusable, and in some cases we check permissions, in some cases we may not. For example, we have a web application, we have a background services system. In background services, no user, so how we will check permission? You cannot reuse this code otherwise. So authorization is a logic of application layer. Again, this writes some logs about the current user. Current user is also a domain service, is not a domain service thing. It creates an organization, good, no problem, inserts the organization to database and some email. Sending email also not core domain logic, and it should be handled in the application layer, or maybe you can just create some domain events and cache or handle this domain events and send email later. So it's best to not do it here. Okay, this is an application service that's used the same organization manager we have created in the previous slide. Application service should be unit of work. That means every use case should be transactional. If you are making more than change on more than one entities, it should be saved as an atomic unit. This is a very important rule. If your database technology doesn't support it, it is another story. But I assume really you are using some kind of transactional database. Authorization also done in this create method. It's reasonable because in this case, for example, this is like in this case we need authorization. It's normal. Then it makes some payment first before creating the organization. If payment fails, it will not create the organization and get an exception. That's normal, and it should be done in the application layer, not in the domain layer. We are creating the organization using the domain service. We are sending email here. It's reasonable because in this use case, we want to send email. And returning organization entity to the presentation layer. It's not true because entities should not be returned to the presentation layer. Instead, we should use data transfer objects. Here, most of the people confuse about why we are making this payment in application layer, but not domain layer, because payment is very important and we should not allow to create an organization without payment. But it's not true. It's not something like application service is also very important. It's not about importance. Think about you have multiple applications, one public website, users are entering credit card details and making some payment. Okay, this is the use case for it. But we have also an administration application. In this case, there is no payment. Maybe someone called us from telephone and, sent me the money from bank or another way and want to create an organization for me. Okay, it's for free. There is no charge. So in this case, we should have another use case without payment. And we should not do that. If it's needed, make payment. If not, like that, like don't merge two use cases together, because it starts to make a coupling between your different screens, between your different use cases, and then you change one, you will get exception from the other one. So this is very typical. So create for every user interaction, like sending a form, clicking something, create a different use case, create a different application service method. Okay, we have 5 minutes, good. I can suggest these books, like Eric Evans has created the domain-driven design concept. It's definitely one book to read, but it's very theoretical book, to be honest, and not easy to understand. But check it. And there is another book like Implementing Domain-Driven Design. This has more practical examples. I can definitely suggest that. Clean architecture. Actually, most of the things I explained today was clean architecture stuff, like defining a val object, implementing solid principles. If you follow these styles, you will already implement DDD, maybe half of DDD. There is another book recommendation that's like 100 pages, short book. Actually, it's written by me. You can download it as a free, as an ebook. This book has created after my first DDD presentation. It's loved very much, and then I converted this talk to a book. You can just download as a reference book. It includes almost everything I explained today. Okay, thanks for watching. If you have questions, we can take.
Hello, thank you. It's very cool practical example how to use DDD in projects. Okay, we have some questions from our chat. First question. Is there a way to use iSpecification interface pattern alongside with, for example, Dapper or RAM, which doesn't provide functionality to use LinQ for filtering data?
In this case, yeah, possible, but in this case, you should create some adapters. For example, converting this specification to SQL or whatever this technology supports. So it's not a topic of DDD actually. I just given the example to make it more practical. However, for infrastructure, you will have an infrastructure layer that supports this technology you are using and translate your domain logic to this technology. You should have some adapter layer for that.
Okay, thank you. And second question. On the side with advice, don't reuse same input data transfer objects for multiple cases. Does it implement any of the principles of SOLID?
You mean don't reuse input or don't reuse?
Yeah, don't reuse same input.
Don't reuse the same objects for multiple use cases. I said that.
Yeah.
So what's the problem here?
I don't know, it's a question.
Maybe it's not very clean. Does it implement any of the? Maybe single responsibility can be related to this topic because every use case makes something different. So it needs some different parameters. If you create a single method that contains all the parameters of 5 different use cases, it works, of course. But then when you make changes for a use case, then all of other use cases will be broken.
Yeah,
so it's not a good idea.
Yeah. Thank you. Friends, do you have any question? No? Okay.
Thank you for great speech about domain-driven design. I very like it, and you got very cool tutorial for this. Thank you.
Спасибо.
I have a question. When you explain us aggregate roots and get an example for issue, you said that we can't mix application layer and domain layer, but in your example, I think that we can improve example if we так. А можно?
Ты можешь задать по-русски, задай по-русски.
По-русски. Но я просто хочу найти это место, во-первых, в презентации, потому что я пытаюсь сейчас... Я по-английски могу его сказать, но я просто пытаюсь вспомнить, где это место конкретно было, поэтому так это выглядит. Вот. А во-вторых, Там была проблема в том, что, значит, создавался вот этот aggregate root, да, issue и так далее, вот, и там одновременно вызывался и репозиторий, и, собственно, обновление. Вот обновление как раз сущностей, update issue, там что-то такое было, да, по-моему. И вот вы сказали, что сущности надо обновлять отдельно, но при этом по коду выглядело так, как будто, почему я не могу попросить слой предметной области это сделать, потому что на самом деле, вот когда мы назначаем issue, да, мы делаем assign issue, это же задача предметной области.
I think it's a very big and complex question. It will be better when Halil answer you in discussion zone. Okay?
Yeah, we can talk about that.
You can point at the presentation this slide and answer your question. Okay?
Okay, time is over.
Yeah, I think timer is over.
Okay, спасибо. Пока-пока.